Newton's third law of motion. So Newton's third law of motion states that every action has an equal and opposite reaction. Or if a force F is exerted by a body on the body B, then at the same time body B will exert a minus F force on body A. The best example to understand Newton's third law of motion is rocket propulsion. As we can see in this figure that a rocket is going to propulsate. So there are a few forces acting on it. The first force that we consider here is force on gases. As the rocket is emitting the force of gases, thus it would allow hot gases to come out from itself, and the reaction of this force would be force on the rocket. Thereby the rocket will move up. We try to understand this again. As the action happens, the reaction will surely happen. As the gases would come out with force from the rocket will move up. The same thing is written here. The emission of gases from rocket acts as an action for the reaction on rocket by forcing it to fly in the air. So let's get into the exercise. The question says a body of mass 5 kg is suspended by strings. That is, a body of mass 5 kg is suspended by strings, and the body makes an angle 45 degree each with the horizontal. The body makes an angle with the strings of 45 degree from the horizontal axis. Here we can see that on the string 2, 45 degrees angle made by the body and the horizontal axis. Similarly, 45 degrees angle being maintained by string 1 and the horizontal axis. Find the string tensions. Let T1 be the tension of the string 1 and T2 be the tension of the string 2. Therefore, and we should also consider force due to gravity, acceleration due to gravity as 9.8 meter per second square. Entering into the solutions, force acting on the body are force of gravity, that is acting downwards, T1, that is force by the string 1, that is tension of the string 1, that would act along the string, T2, that is tension of the string 2, that would also act along the string, along the second string. T1 is along the first string, T2 is for along the second string. Thus, taking horizontal components, we can write as T1 cos 45 is equals to T2 cos 45. How we can write that? Since this is making an angle 45 degree with in between string 2 and the horizontal axis, if we consider this as a right angle triangle and apply trigonometry rules, thus in the horizontal axis we can write it as T2 cos 45. In the similar fashion, here string 1 is making a 45 degree angle with the horizontal axis. If we consider this as right angle triangle and apply basic trigonometry rules, we can write the force acting on the horizontal axis is T1 cos 45. Therefore, while taking the horizontal components, T1 cos 45 is equals to T2 cos 45, or cancelling out cos 45 from LHS as well as RHS, we can write as T1 is equals to T2. Let's name this equation as equation 1. Further, taking vertical components in the free body diagram, we can write T1 sin 45 plus T2 sin 45 minus mg is equals to 0. Let's find out why it is written like that. Again, consider this. The string 2 is making 45-degree angle with the horizontal axis. If we consider a right angle triangle here, then we can assume that by applying trigonometry rules, this side would be is equals to T2 sin 45 degree. Similarly, this side would be is equals to T1 sin 45 degree. As string 1 is making 45-degree angle with the horizontal axis, and we are considering this as a right angle triangle. Also, we are in the vertical direction, there is acting force due to gravity. This force due to gravity is mg, and it is acting in the downward direction. Therefore, a negative sign would be add up with this. Therefore, taking total vertical components, we can write it as T1 sin 45 degree plus T2 sin 45 degree minus mg is equals to 0. From equation 1, which was showcasing us T1 is equals to T2, we put that in here. Thus, this equation of vertical components T1 sin 45 degree plus T2 sin 45 degree minus mg is equals to 0 can be written as T1 sin 45 degree plus T1 sin 45 degree minus mg is equals to 0. Since T1 is equals to T2, we have already seen in equation 1 here in previous slide. Therefore, by putting values to these equations, we consider that sin 45 is 0.707 and acceleration due to gravity is 9.81 as provided in question. Thus, T1 into T1 sin 45 would be T1 into 0.707 plus T1 sin 45 again, that would be T1 into 0.707 minus mg. Minus mg would be m is 5 kg. So minus m into 9.81 is equals to 0. Further, taking common from these equation, we can write it as twice of T1 into 0.707 minus 49.05 is equals to 0. How we are able to write this? Twice of T1 into 0.707, as this is the first time we are getting this T1 into 0.707 in this equation. This is the second time we are seeing this T1 into 0.707 in this equation. So therefore, we are able to write it as twice of T1 into 0.707. And how we got 49.05? 9.81 when multiplied by 5 gives the results 49.05. Therefore, equation is twice of T1 into 0.707 minus 49.05 is equals to 0. Thus, T1 is equals to 34.65 newtons. Thus, we can find it out as the tension applied on the string 1 is equals to 34.65 newton. As from the equation 1, we have seen that T1 is equals to T2. So, string 2 would also be facing a tension of 34.65 newton. Let's get into the another exercise. The question says, if a cable supporting an elevator has a tension of 1.5 kilonewton, calculate the elevator's weight. while considering acceleration due to gravity is equals to 9.8 meter per second square. Let's see this in free body diagram. So this is an elevator of mass m. Let's say its mass is m and it has been supported by a cable of tension T1, where T1 is equals to 1.5 kilonewton as given in the question. We have to consider that acceleration due to gravity is 9.8 meter per second square. So if we consider this as system, are two forces acting on this system. The first one is T1. The second one is force due to gravity. That would be is equals to m into g. G is 9.8 meter per second square and m is the mass of the elevator that we have to actually find out. So considering mass of elevator V m, and we are taking vertical components since there are no horizontal components in this, therefore tension of the cable T1 would be equal to weight of the elevator, that is m into g, where they have usual meanings. T1 is the tension on the string 1, there is only one string attached, tension on the string 1. M is mass of the elevator and g is acceleration due to gravity. Putting values to these equations, we can write as 1500 is equals to m into 9.8. Thus m, that is mass of elevator, is found out to be 153.06 kgs. The next thing we are going to study is force. What is force? What is its units? So, force represents the push or pull on an object and alters its velocity. This can also be written as force is equals to mass into acceleration. Since it alters the velocity, so there will always be an acceleration. The picture depicts the same. A body of mass m moving with an acceleration a. It is due to the force that would cause a force. Force would be equals to mass into acceleration. Thus, its derived unit is kg meter per second square. Kg is the unit of mass, meter per second square is the unit of acceleration. So the unit of force will be kg meter per second square. This can also be written as Newton. Thus kg meter per second square and Newton have same meaning. As the force has both magnitude and direction, therefore force is a vector quantity. Another way to describe force is as an external agent that alters a body's state of rest or motion. Likewise, here a body was at rest and the force on the application of force, it starts to move. The similar thing can happen if a body is moving and a braking force is applied to deaccelerate the body and to make it at rest. The next thing we are going to study is types of forces. Force can be categorized into 4 types: gravitational force, electromagnetic force, nuclear force, and weak force. Where gravitational force and electromagnetic force comes under the category of classical physics, and nuclear force and weak force comes under the category of quantum physics. We have already seen this table before on the day 1 course, where I have classified this as when the particle size is termed to be greater than 10 power minus 6 meter and the particle is moving with less than the velocity of 10 power 8 meter per second, then it comes under the category of classified physics. Therefore, in classical physics, gravitational force and electromagnetic force will work on it. In the similar manner, if the particle size is less than 10 power minus 6 meter and the particle is moving with a velocity of 10 power 8 meter per second, then quantum physics would be applied on it. Application of quantum physics means the nuclear force and weak forces will be applied on it. Let's study in detail what is gravitational force. Newton's law of universal gravitation is usually stated as every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Also, Earth's gravitational force is called gravity. Let's try to understand this definition again. Every particle attracts every other particle in the universe. The first half of the statement is every particle attracts every other particle in the universe with a force, and that particular force is directly proportional to the masses of both particles, and that particular force is inversely proportional to the square of the distance between their centers. Let's try to understand this gravitational force using an example. Let m1 be the mass of the first body, m2 be the mass of the second body, and r be the distance between the two bodies. Here in the picture we can see that m1, this is the first body and the mass of the first body is m1. This is the second body and we have considered the mass of the second body as m2. And as per the gravitational force, both the bodies will be applying force on each other. And the distance between the center to center distance between the bodies is considered to be r. Therefore, from the definition, we can make out that the force acting is directly proportional to mass of the two bodies, m1 and m2. Also, the force acting is inversely proportional to the square of the distance between them. The square of the distance between them here is r. Therefore, combining both equations, force can be written as equals to G into m1 into m2 divided by r square, where G is the proportionality constant and can be called as universal gravitational constant as well. And the value of G is equals to 6.67 into 10 power minus 11 Newton meter square per kg square. Gravitational force by Earth on small bodies. That's the next thing we are going to study. Consider mass of Earth as me is equals to 6 into 10 power 24 kg and the mass of the object be m2 kg and the radius of the Earth is equals to 6400 kilometer, where these are actual facts. Mass of the Earth is 6 into 10 power 24 kg. Radius of Earth is 6400 kilometer. Since the object is placed on the Earth's surface, the distance between the Earth and the object is equal to the radius of the Earth. Hope you have got this. The object of mass m2 is placed on the surface of the Earth. So, the center to center distance between the object and the Earth would be is equals to radius of the Earth, that is 6400 kilometer. Hence, the gravitational force can be written as F is equals to G me into m2 upon r square. Here me is mass of Earth and G is gravitational universal constant. m2 is mass of object. Thus, this equation can be written as 6.67 into 10 power minus 11, which is the value of universal gravitational constant, into 6 into 10 power 24, which is the value of mass of Earth, into m2, that is the mass of the object, divided by 6,400 kilometers square, which is square of radius of the Earth. This can be simplified as taking constants at one end and m2 at the other. So constants into m2. Further, these all constants can be covered by a single word called g. This is acceleration due to gravity. If we calculate these constants, we would get a number called 9.81. Here, g is acceleration due to gravity and would equal to 9.81 meter per second square. And g is considered to be same for objects placed on Earth. Thus, to simplify the calculations, we have considered a constant named as small g, which is called acceleration due to gravity. Thus, the formula for calculating the gravitational force by Earth on small bodies placed on it changes to F is equals to g into m2. m2 is mass of the small body that has been placed on the Earth. Let's try to understand this using an example. Here, as the question given, calculate the gravitational force acting between the Earth and the Sun. Considering mass of the Sun is equals to 1.99 into 10 power 30 kg. Mass of the Earth is equals to 6 into 10 power 24 kg. And distance between the Sun and the Earth is equals to 1.49 into 10 power 11 meters. So we have got mass of Sun as ms. We denote it by ms. So mass of Sun is 1.99 into 10 power 30 kg. Mass of Earth, that is m2, or here in our case is me, is 6 into 10 power 24 kg. Center to center distance, that is r, between Sun and Earth is given as 1.49 into 10 power 11 meter. So, as per the formula of gravitational force between two bodies, F is equals to g into ms into me divided by r square. Ms can be termed as m1, that is mass of first body, that is mass of Sun. Me can be termed as mass of Earth or mass of second body. Thus, putting values to this equation, we can write it as universal constant value is 6.67 into 10 power minus 11 multiplied by 1.99 into 10 power 30, which is the mass of the Sun. Further, this is multiplied by 6 into 10 power 24, which is mass of the Earth. And this whole is divided by r square, that is center to center distance between the Sun and the Earth, which is 1.49 into 10 power 11 meter whole square. On summarizing this equation or solving this equation, we get that in the numerator is equal to 79.64 into 10 power 43 to be divided by 2.22 into 10 power 22. And thus, the force acting between the Sun and the Earth is equals to 3.587 into 10 power 22 newtons. Thus, gravitational force acting between two bodies, Sun and Earth, is 3.587 into 10 power 22 Newton. This is also the answer of this question. Here we close our session 3.